So, here are the answers. Number 2 and 4. Number 2 is W equals negative 3. 4 is C equals negative 2.
Are you going to check it?
Huh?
Are you going to check it?
Am I going to come check it?
Yeah.
No, I don't think so. Why'd you do it? I mean, you're going to get a good grade on it. Everybody.
Nobody else.
Yeah, I'm gonna come check it.
We just checked.
What's it? Hey, good job, bro. Extra credit? No, just normal credit. Okay, number 6 was R equals 7. Number 8 was N equals 4. Sorry that I said 2 through 20 even. It was only 18. That's my bad. Number 10, H was equal to 1/4. And number 12, it was negative 10. Number 14 and 16. 14 was 5/12. That's the one I probably would have said was the hardest. 16 was negative 8. And the last one was negative 9. All right. So which ones do I need to go through with you? All right, what you got? Number 8. Okay, another. I'm going to mark them all, and then we're just going to go through them. 14, 16, I heard. 14 and 16. 8, 14, 16, is that it?
12.
Number 12. So 8, 12, 14, 16. Is that solid? That'll get us, right? Okay. If there's another, though, catch me, and we'll go through it. And we'll have a little time, I think, today. So number 8. The first thing I like to do is, well, actually, two-sided. But in this problem, the first thing I would do is I would recognize on this left side, both of these have a base of 4, right? So when we have the same base and we're multiplying, what's the rule getting those together? You add your exponents. Now you got to be careful because a lot of times what we think is because those are numbers, 4 and 4, and they're not x or variables. A lot of times people will try to change those. But here's the rule. When you multiply and your bases are the same, the base stays the same and we add our exponents. So I'm going to go n plus 2n, which is what? So I'm going to be left with 4 to the 3n minus 9 power. Now, on the other side, can we make 64 have the same base? All right, 4 times 4 is times 4. So we're going to change 64 to have the same base, 4, to what power? Now, why? What's the purpose of us doing that? That's it. If I can create them to have the same base, or if they have the same base, these didn't, but if I can create them to have the same base, like I did right here, I can drop the bases. And if I can drop the bases, then we've just got a simple equation to solve. In this case, it's 3n minus 9 equals 3. So I do what? Add that 9, right? 3 plus 9 is 12. And then divide by 3, so n equals 4. Okay? And that's it for number 8. Okay? Let's move along to number 12. Now, in this particular case, there's nothing that we need to combine like we did on that last problem. So I look at the base, this one's 16, and this one's 64, and I'm just going to kind of tell you my line of thinking. I look at the smaller one right here, 16. I'm going to try to make 64 have a base of 16 in my mind, right? So 16 times 16, what do you get? Way over 64. Here's the point. Can I make 16, or can I make 64 have a base of 16? Then this is one of those situations where I realize I'm going to have to change both bases. Okay? So what can I make 16 and 64 have in common? 4. Okay? I need to create both sides to have a base of 4. So let's start with 16. 4 times 4 is, so 4 squared gives me 16. Now don't forget, if there's a variable already there, you let it stay there, and we'll deal with that in just a second. Go to the other side, 64. We already said that 4 times 4 is 16. Times 4, 64. There it is. 4 to the third power. So 4 to the third power gives me that 64 that I needed. And that r plus 2 has to stay put. We created both sides to have a base of 4. Why? So we could drop the bases. Now, in this particular problem, was that all you could have done? Well, we're going to do distributive property. But I'm saying, is all I could have done here base 4? You actually could have done base 2. Yeah. I'm just saying, you have options on some problems. 2 would have worked for 16 and for 64. So if you happen to have gone that route, it's not wrong, okay? But base 4 worked perfect here. They're gone, and now I distribute and solve. What's 2 times r minus 2? 2r minus 4 on the left side. And on the right side, what's 3 times r plus 2? 3r plus 6. All right, I'm going to subtract the 2r. That will leave me with negative 4 on the left side. What's 3r minus 2r? Plus 6. I'm going to get r alone by subtracting 6. Negative 4 minus 6 is negative 10. So my answer, negative 10. Okay, that's number 12. All right, number 14. All right, first thing I'm going to notice is my base here is a 4. It's in the denominator. This base here is 32. It's not in the denominator, it's in the numerator. So I'm going to try to make 32 have a base of 4. What's 4 times 4? 16 times 4. I just went right past what? I went right past 32. So I cannot do base 4. So I have to change both sides. What can I have 4 and 32 have in common? I have to get it to 2, base 2. So I look at 4 in the bottom. How can I make that a base 2? 2 squared. Okay? And then, of course, for 32, what's 2 times 2?
4.
Times 2? Times 2? Times 2? There it is. 2 to the 5th power. So here we go, okay? Because on the left side, that 2 squared is in the denominator, what did I show you Friday you do when you have that fraction? You use a negative exponent. So I'm going to move that 2 up top using negative 2 as my exponent. Now remember, there was already a 2x up there, so let's leave it. And then on the right side, I changed that 32 to 2 to the 5th. There was already a 4x minus 2 up there, so I leave it. Now, I can drop my what? I can drop my bases, okay? So on the left side, negative 2 times 2x. And on the right side, 5 times 4x is 20x. And then 5 times negative 2, negative 10. Now, you have a couple of options here, and I'm not real picky. You could move the negative 4x to the 20x. You could move the 20x to the negative 4x instead of, loading up one side. Which way did y'all go, just curiously? You moved the 4?
Yeah.
Okay, so you added 4x, right? So that actually leaves nothing over here, unless y'all did 2 steps at once, which is fine. But 20x plus 4x is, and then the minus 10 drops down. I'm going to add the 10, and then I'm going to divide by the 24. And 10 divided by 24 as a fraction or as a decimal is not beautiful. It's like 0.416 repeating. If you went that route, please don't round to tenths. If it's not a really, really pretty rounding number, let's go to at least 2 decimals. In this case, I probably would have done either 0.42 or 0.417 if you're rounding. Or preferably, if it's a number like this, I would probably prefer you write it as a simplified fraction, and that was 5 over 12. Okay? But again, not going to be overly picky with that. Questions about that one? Okay, 16. The good thing about 16 is finding the base that you're going to use is pretty simple. What can 9, 3, and 3 have in common? It has to, right? Think about it. You can't take 3 down anymore. Nothing will multiply by itself to get 3. So 3 has to be your base. What can you multiply to get 9 with a base 3? 3 squared, right? So because it's a fraction, what do we know we're going to do with it? Negative exponent, right? So that's going to become 3 to the negative 2. And don't forget there was already an a up there. So we can go ahead and distribute that. And that gives me 3 to the negative 2a. You with me on that? How about this 3? How do I move it up? Yeah, because technically it has an exponent of 1, doesn't it? So I can move it up and make it a negative 1a. All right? So what's next? Because I can't do anything with the right side. What can I do with the left side, though? Because we're multiplying and the bases are the same, we can combine those bases, stays the same, and we do what with our exponents? So what's negative 2a plus negative 1a? All right, and that equals 3 to the 16 minus a power. So we have combined it. Our bases are the same, so we can drop them, and we can take negative 3a and set it equal to 16 minus a. What did y'all do first here? Did y'all move the negative 3a or did y'all move the negative 1a?
Negative 2a.
Yeah, I think I moved that negative a too. I added a. What's negative 3a plus a? So negative 2a equals 16. Lastly, divide by negative 2, a equals negative a. And that's it. Okay? What y'all think? Not too bad, right? Okay. All right. So today we're going to review for a quiz. Y'all are going to take a quiz tomorrow. It's going to be a really easy quiz. I mean, when you see this review, you're going to realize that I can't make this easier than I'm making it. All right? Yes, easier than that even. It's going to have 7 problems plus a bonus. The 7 problems are cake. The bonus is kind of a mixture of what we just saw on 14 and 16. It'll be, here's how it's like 14. It's like 14 in that you'll have to change both bases. It's also like 14, it's like 14 in that you'll have to change both bases. It's like 16 because you're going to have to combine 2 on one side. So it's kind of like a mixture of 14 and 16, and that's a bonus problem. So it's a true bonus. Like, you don't even have to try it if you don't want. But the actual quiz, which is 7 questions, is going to have 4 questions that are like numbers 1 through 6, and it's going to have 3 questions that are like numbers 7 through 10. And I can't have made 7 through 10 any easier, right? Look at them real quick. They're really simple. I do want you to make one quick little change. On number 5, I would love for you to add a negative out in front. Can y'all see that? Add a little negative out there. Okay? So, on numbers 1 through 6, we got to answer 4 questions. 1, we got to state whether it's growth or decay. Okay? Very simple. Then, number 2, or B, just as simple. You have to state whether it is, or what the parent function is. Then, C, you're going to name the transformations. And then D, you're going to name the asymptote. Okay? So let's start. And we're gonna knock this out pretty fast. So let's start with A. And before we do A, please remember, here's what I expect. I expect you start this problem by looking at the exponent and its base. Right? That's where you should start. You see, if I can look at the base of that exponent, it immediately lets me determine whether it's growth or decay, right? What's this one? How do we know? Is there such thing as equal to 1 in an exponential? Okay, so greater than 1 means what? Growth. And less than 1 means decay. So what's this one? Definitely growth. Easy, right? B, the parent function. Remember, it's saying, hey, looking at this particular function, what would be the simplest version of this graph with no transformations? 3 to the x power. That's it. That's your parent function here. Everything that's not 3 to the x is what we call a transformation. And that's where we're going to go with C. Transformations. So what y'all see? Okay, remember, in the exponent spot is what we call horizontal shift. Horizontal shift. And remember the rule on horizontal shift? It's the opposite. It looks like a positive 4. It's actually going to be a negative 4 horizontal shift. So it shifts. Which way is negative? Left, forward. So that takes care of that one. And what other transformation do you see? It shifts down 1. Remember? On the outside, we called that K. We said that's vertical shift, and we said it is what it is. So that looks like a negative 1. It is a negative 1. It goes down 1. And kind of right in line with that, when we said there's no transformations, what is the asymptote for every exponential function? Y equals 0. Remember, it's a horizontal line. So horizontal lines only cross the y-axis. So y equals 0. No transformations. What transformation do we say will cause that y equals 0 to change? The vertical shift. Did we have a vertical shift on this problem? So where did my equation go to? Y equals negative 1 is my new horizontal asymptote. Okay? That's the new equation for my horizontal asymptote. Please don't forget that it is an equation. You have to put the y equals negative 1. Don't just put negative 1, because that's not describing the equation. That is your horizontal asymptote. Okay? How easy is that? I mean, are y'all good with this? We go pretty fast then, right? Recognize your variable in your exponent spot and its base. So guys, growth or decay? Decay. That's definitely less than 1, right? B, what is that parent function? 3/4 to the x, right? It's whatever that base is to the x power. All right? Everything that's not, whatever that base is to the x power, is what we call a transformation.
Why is it decay?
Because that base of that exponent, 3/4, it's less than 1.
Why wouldn't it be 2?
Because that 2 is the a value that's out in front. And basically that a value that's out front, it's either it's affecting your decay or growth. So that 3/4 is your base. That's telling you it's decay. The 2 out in front, that's telling you that it's taking this graph that's decaying and it's vertically whatting it. It's vertically stretching it. Okay? Now I have had people in the past, not this year, but I have had people in the past that would say something like this. If you multiply 2 by 3/4, it's greater than 1. But here's the thing. Are you allowed to multiply before you deal with exponents? No. Then this right here, being an exponent, says this graph is decay. That 2 is just going to take it and cause it to stretch. Okay? You can't multiply before you exponent. All right? So, is that the only transformation? What else does this thing do?
Shifts.
It shifts to the right 7. So here's a good question. If all it did was have a vertical stretch and shift to the right 7, what is my asymptote? Y equals 0. It does not change. Why? What causes your asymptote to change? Vertical shift. And this had no vertical shift. Yes, sir. Yeah. Killing it. All right. Any questions about that?
Vertical stretch, can I write vertical stretch after shift stretch?
Yeah. The order you write it doesn't bother.
Okay.
Whatever. Yeah. No, that's perfectly fine. As long as you have those two, that's all I care about. Okay? Only reason I write it first is I like to move left to right. So I see the 2 first. Okay? No big deal. All right, so look at number 3. Find your exponent in the variable in the exponent spot and its base. So guys, A, growth or decay? Growth. B, what is the parent function? 2 to the x. Whoever misses those tomorrow, I might beat you up. C, transformations. All right, I see a 1/3 out in front. What's that tell me? Vertical compression. It's smashing the graph. Because that's less than 1, right? It's taking this exponential growth and it's just smashing it. So it doesn't grow quite as fast. All right, then I also see what? A shift to the right 2. And then lastly, I see a shift up, because that's a positive 4, up 4. And because of that vertical shift, up 4, what did my asymptote move to? So we're going to write what? Y equals 4. That's my new asymptote. Okay? I guarantee if you graphed it, you'd see that. All right. Any questions on 3? All right, number 4. Find the exponent or the variable in the exponent spot and its base. Is that growth or decay? Definitely. What's my parent function? 5 to the x. C, what's my transformations? Shifts left 1, right? Or correct, I mean. Shifts left 1, and then it also shifts up 2, which causes our new asymptote to be located at y equals 2. Following? Brady, you with me again? Okay, number 5. Find the variable in the exponent spot and its base. And is this exponential growth or exponential decay? Definitely decay. B, what is that parent function? 1/2 to the x power. Everything that's not that is a transformation. So what's that thing out front tell me? It reflects over the x-axis. Okay, is that all? It also shifts down 6. Look, guys, that is clearly on the outside. It's definitely not up here. It's on the outside. That's vertical shift, down 6. So therefore, what is my new asymptote? All right. And then the last one, you're not going to have one like the last one. Just trust me in that. There will be a transformation. Yes.
At the B, do we have to provide the parentheses?
No. Since that's all there is, you don't really need that. If you put it, it's not wrong.
But if there would be not like parentheses, it means like x over for 1.
Not if you write it as a fraction. Like if I wrote it like 1 divided by 2 to the x, then I agree. But if you write this as a fraction bar, that number is connected to each other, so it's saying that whole thing is raised to the x power. The difference would have to be written like this. It would have to be like 1 to the x over 2. Does that make sense? That would be the only thing that I would say, okay, just the 1 is to the x power. Does that make sense? But since you have just the 1 over 2 and the x, it would be my understanding that the whole thing will half is raised to the x. But if you want to put it in parentheses, that's perfectly fine. All right. I do see what you're saying though, for sure. Okay. Let me see what happened here. Okay, and the last one, like I said, don't expect this one because I don't know how this even snuck in here. But is it growth or decay? Definitely growth. What about that parent function? It is it. You're looking at it, right? It's 2 to the x. Therefore, as far as transformation goes, what would you say? There is none, okay? And then lastly, because there's no vertical shift, what's the asymptote? Y equals 0. So expect more of those 4 problems tomorrow to look like 1 through 5, okay? I'm not going to give you one like number 6. There will be a transformation of some sort, okay? It might only have one, like number, well, none of them have just one, did they? But you will not have one that has no transformation, okay? All right, any questions before we move along? Now, I tried to make these pretty simple because, in all seriousness, if you're going to use this method, you're going to use this method for pretty simple ones. For the ones that are a little harder, more than likely you'll use the other method that we'll probably be talking about on, I guess it's Friday, it'll be Friday. Anyways, like number 7. Why is this one so easy? Already has the same base. So what do we get to do right off the bat? We get to just drop off the bases, right? So we can set 3x minus 5 equal to x plus 9 and solve. So what process would I go through here to solve? Get my variables together, right? So I'm going to subtract x. What's 3x minus x? So 2x minus 5 will equal a 9. And then, what's 9 plus 5? 14. And then lastly, divide by 2. 14 divided by 2 is 7. So real simple one there, right? You'll have one of those tomorrow on the quiz. Because you'll have one of those more than likely on an EOC test. When the bases are the same, you drop the bases. Number 8, a little harder, not much, because obviously we don't have the same base. But which one do I need to change? About time. Guess must be nice. Oh, you're gonna drop off a drink. Let me guess who's getting that.
I don't know.
You know what? If you're gonna bring a drink to someone in here, maybe you should bring a drink to everyone. I hope you really enjoy that, Jaden. Sure. All right. So we're gonna turn 4 into a base of what? How? Not square root. We're gonna square it. So we're gonna do, in lieu of 4, we're gonna do 2 squared. So this side already has a base of 2. Don't mess with it. But this side we're gonna change to 2 squared. That way they both have that base of 2, and we can what? We can drop the bases. So we're left with 2x plus 10 equals 2. So we're going to solve this by Subtracting 10. What's 2 minus 10? Negative 8. Yeah, and then we're going to divide by 2, and we get negative 4. I know you wouldn't have made that mistake on a quiz. I get fast sometimes too and make mistakes. All right, number 9. This one tests what? Our ability to remember what? Negative exponents. If I've got this base of 5, and this is a base of 5, actually, this is not base of 5 on the right side, it's base of 1/5, but we can make it a base of 5 by remembering how do I move it up? Negative exponents. So I'm leaving the 5 to the 4x plus 15, but I'm going to make this 5 to the negative 1, okay? Now I can drop off both bases, and it's a simple solve. 4x plus 15 equals negative 1. What's my first step? Subtract 15. Yeah, I know y'all know this. Y'all just not wanting to help me. Negative 1 minus 15, and then divide by 4. And there you have it. Easy peasy. Yes, ma'am.
When you're doing the negative exponents, whatever is in the numerator is what's going to be the negative exponent, or it's not always 1, right?
Right. Like, for example, I think I understand what you're saying. Like, for example, if this were 1 over 25, right? See, how could I make 25 have a base of 5? It'd be 5 squared, right? But where is that 5 squared at? In the denominator. So I can't let it cancel with the other base of 5 in the denominator. So I move it up to the top. And when I move it up to the top, it causes that exponent to turn to negative. And then now it's a base of 5. So same thing here. This was 5 technically to the first power, but it was in the denominator. So I need to move it up, and that's what allowed the 5 to go up top. But I had to change that exponent to negative. Okay?
Do you have a 2 or just be the same?
Well, if it were 2 over 5, you wouldn't be able to do that.
Or, well, you know, like, one that you could, like, change.
Now, no, you couldn't change it. You wouldn't be able to change it. If it were 2/5, you're going to use the other method that we'll talk about on Friday. Okay? Because see, the problem with 2/5 is I can't write it like this. No, you couldn't. I was trying to think through a scenario where maybe I could, but you can't. Okay? You would use the other method. Really? Is that hard on you right now? I mean, jeez, Louise. I didn't know it was that tough.
You just started listening. I mean, heard there might be a chance to be.
Oh, I don't think so. I think he just didn't realize how loud that was going to be. Is that? Okay, last one. Again, it's about as hard as it's going to get on the quiz, except for the bonus. And it's not even that hard because you don't even have to change both of them, do you? You can make 64 have a base of 4, right? 4 times 4 is 16 times 4. There it is. So we can change 64 to have base what? I'm sorry, base 4 to what power? To the third, 4 cubed. Okay, so very simple. These are going to cancel, drop the bases, and then you can simply solve 3x minus 3 equals 3. Now what? Add 3, 6, divide by 3, x equals 2. Okay? So, again, tomorrow you'll have 4 problems that are like 1 through 5, not number 6, right? So you'll have 4 of those where you have to state whether it's growth or decay, write the parent function, write any transformations, and what the new asymptote will be. Then you'll have 3 that are very similar to 7, 8, 9, and 10, but then you're going to have one bonus that's going to be a mixture of 14 and 16 on the notes, or on last night's homework assignment. So, it should be easy. No homework except being ready for your quiz tomorrow. Okay? Yeah, it's a good Monday, right?
I mean,
Ready?
have a-
Oh,
they use the rest.
oh. Jeez Louise. What does the review say on it? Yes, ma'am.